Hello, everybody, and we will be covering homework 9 in this one. This goes very closely with homework 8, so you may want to, I wouldn't say watch them back to back. Make sure you've done homework 8 before you get into homework 9, but homework 9 builds directly on top of what we talked about with homework 8. All right. Homework 9 is actually another exponent rule. Remember the 3 rules we talked about in homework 8, product, power, and quotient rule. Homework 9 is another of them. And this one is the rule. It's really not a named rule so much, but it's negative exponents. And it's its own whole thing. This actually won't be a super long lecture. In fact, I'm going to be done with the definition for negative exponents in probably about 5-10 minutes. We'll do some examples, of course. But the issue here is this just, if you have any weakness with the stuff from homework 8, this is going to find it and exacerbate it. It's going to make it worse. Now, we talked about negatives with exponents, like if it's -2 in the parentheses or -2 out of the parentheses, right? You know, we said stuff like, we were talking about stuff like this last time. That's not what I mean, because those are not negative exponents, right? The exponents here are positive. And you really, unless the order got messed up, which you shouldn't have had any negative exponents in homework 8, all right? So negative exponents, what do they do? What are they? Let me go and say this first. They do not make things negative. That's the first thing to get out of the way, right? Because it's just obvious. It's the first thing that people think. A negative exponent makes things negative. They do not. If you have a positive number with a negative exponent, it will not be negative. It's going to stay positive, okay? So I've found the easiest way to do this is just to show 2 examples rather than trying to write out some long, wordy definition. So I'm just going to show you a couple examples, and you'll see what negative exponents do. Keep in mind when we do the problems as we go, and it gets a little more complicated, it's just one rule, and the one rule can make things kind of ugly. The other thing real quick about negative exponents is you cannot, and this is important, well, it's all important, right? You cannot leave them in your answer. And that's, you know, because otherwise you could just have a negative exponent, just leave it in your answer and be done. If you leave a negative exponent in your answer, it's wrong immediately, guarantee it. If any answer that you leave on that test or homework or quiz or worksheet or anything, if you leave a negative exponent in it, it is wrong. The only thing I can think of that would say that that's not true is scientific notation, which is not what we're talking about here. So unless the problem tells you leave negative exponents, and it won't, do not leave them in your answer. So what do they do? 2 examples, and hopefully it'll be clear. So let's say we had 3, let's do -3. -3 x to the 3rd y to the -6, right? Now you might look at that and say, well, there's nothing to do because everything's already combined. Why is the color changing? I think the color through the window is changing. Sorry about that. So we have -3x to the 3rd y to the -6. The sunlight through the window keeps changing, messing up the focus. So you look at that and you say, well, there's nothing to do. The x's don't combine with y's, the y's don't combine with x's, and the -3, which remember is called a coefficient, doesn't combine with anything. It just sits there. Well, right, but remember I said you can't leave them in your answer. So if you worked out a problem, you know, you got it all down to here and that was where you were at, that's not your answer. Your answer would look like this. So take a note of what just happened. We'll talk about it in just a second. Let me give you one more example. Let's say I said 4a to the 3rd over 5b to the -2nd. All right, same thing. The a's don't combine with the b's. 4 and 5 can't reduce, so you'd say, well, what is there to do? Well, remember, you can't leave negative exponents in your answers. And again, I shouldn't do that. You're going to think it can't. These are 2 separate things completely. Do not think one bleeds into the other. What I was saying is, if you did a bunch of work and got down here, you know, you did a quotient rule and you cleared it all up, and there was a's and b's and blah, 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 that's not your answer. Your final answer would be this. 4a to the 3rd, b to the 2nd over 5. So take a look at these 2 examples and tell me in your words, what do you think negative exponents do? One sentence, make this easy. They don't go to the bottom, right? You had -3x to the 3rd, y to the -6, and y to the 6th ended up. What do you mean they don't go to the bottom? That's exactly what just happened. Now, that's not what happened here. Here you had 4a to the 3rd and 5b to the -2nd, and it ended up on the top. So what students like to say is that negative exponents go to the bottom. That's not true. Negative exponents, and I'm going to abbreviate here so I don't run out of room. Negative exponents switch sides right? If they're in the numerator, they end up in, if they're in the numerator, they end up in the denominator. If they're already in the denominator, they end up in the numerator. So negative exponents switch sides and go positive. Look at the two examples I did and convince yourself that's what happened. -3 is not an exponent, remember. That's not an exponent, it's a coefficient. So it just sits there. X to the third is not negative, so it's not going to move. Y to the -6 can't have a negative exponent. They switch sides. This is all on the top because we didn't say otherwise. So it moves to the bottom and became positive. Here we had 4a to the third, 5b to the -2nd. 4 is not going to move. Why would it? The 5 isn't going to move. Why would it? The a to the third is positive. It's not going to move. The b to the -2nd is going to move to the top, switch sides, and become positive. So that is all negative exponents do. And you might say, well, you know, why are you making such a big deal out of this? You tell me, because what happens is students are all good on homework 8. And then as soon as we get into homework 9, they start having trouble. So I don't know exactly what the problem is. That's all they do. I think what it is, it's students are overconfident about homework 8. They're not really that clear on 8. And then 9 just makes it worse. So if you're having trouble with 9, step back and make sure that your trouble's not actually with homework 8. So what we're going to do now is really just do examples. That's the quote, or excuse me, that's the negative exponent rule. They switch sides and they go positive. That's it. That is literally it. So what I would tell you to do is think about a negative exponent as like a flag waving in your face. I'm in the wrong place, right? This y to the -6 is in the wrong place. It needs to go to the other side. And it did, and it became positive. Here we go down here. We got this b to the -2nd. It's like a flag waving in your face. I'm on the wrong side. Move him to the top, and he's good. Okay? And keep in mind as we do these problems, that is quite literally all that's happening here. All right? Because what happens is, again, it gets complicated and people get confused. So let's say we had a product rule. Let's start back up with the product rule again. Let's say we had -2, x to the third, y to the -4th. I mean, they might just start you off with the negative in the problem. You might not have a choice. Times, let's say 3, x to the -2, y to the -10. All right? And it tells you to combine those or simplify them. You're still going to do the product rule just like we did in the homework 8. Remember, -2 and 3 are coefficients. They are not exponents. So -2 times 3, that's -6. No big deal. Just like it always was. Here you have 3 x's and -2 x's. We're supposed to add these together. Well, 3 and -2 makes x to the 1, which we don't write. It's just x. 3 minus 2 is just 1. Here you have -4 y's and -10 y's. So wouldn't that be -14 y's? The reason I do it like this, rather than just dropping everything right away, which you could do, is I want to clean it up first, yeah? Simplify it first. Put your x's together first, because if you do that, you found, well, they really weren't negative at all. The y's did end up staying as a negative power, but the x's didn't. So if you had moved this x early on, you'd have to move it back, and it's just a big pain. Combine them first, see what you get, and then move things that need to move. So you work this out and you get the following. Are you done? Well, no, because you cannot leave negative exponents in your answer. So one more step. The -6 is not going to move. It's just a negative number. Negative numbers don't move. X is not going to move. It's just a variable, or it's just a variable with a power of 1. The y to the -14th will go to the bottom because it was on top and become y to the +14. Take a minute. Make sure you're clear on that. It's not the only way to do the problem. You could drop the y to the bottom and the x to the bottom and then clean it all up. And I mean, my God, I couldn't think of a more complicated way to do it. So keep that in mind. There are multiple ways to get to the same answer here. If you do it a different way and you get the same answer every single time, well, what you're doing isn't wrong then. You're just doing it differently, okay? So that's what it might look like with the product rule. What might it look like with the quotient rule? Well, let's actually skip that for a second. Let's do the power rule. The quotient rule, as usual, is a little bit more complicated. Let's skip to the power rule first. So this is, again, this is product rule. What does it look like when you have a product rule with negative exponents in it? Here, we'll do the power rule. So let's say we had, what would be a good way to, oh, here we go. Let's say we said -3, a to the -3, b to the 5th. And let's say the whole thing was raised to the -2. So again, there's multiple ways to do this. One way to do this is to drop the whole thing to the bottom because the whole thing's doing negative power. And honestly, that's the way I would personally do it. I have not really gotten a lot of success with students teaching it that way. Like 30% seem to get that. What I have found is teaching it the way I'm going to show you. But again, remember, as long as you get the final answer and your work makes sense, I don't care how you do it. So this is not the only way to do it. Keep that in mind. So the way I do it might seem tedious, or hey man, I did it a lot quicker and did it a different way. If you're getting the same answer, you're doing it right. Here's what I would tell you to do. Rather than dumping all this under one or something weird, just isn't it -3 to the -2, a to the -3rd to the -2, and b to the 5th to the -2? Aren't all of these to the -2? We'll just do them all to the -2 then. So what we'd have is -3 to the -2. I'm just going to write it quite literally. -3 to the -2. It came out of parentheses, so it stays in parentheses. What happens when you do a power to a power? What did we say? That's power rule, right? Power to a power, they multiply. -3 times -2, that's a to the +6, right? Here we have b to the 5th times -2, 5 times, or excuse me, b to the 5th raised to the -2. 5 times -2, that's b to the -10, right? This was to -2 power, which we just wrote. We had -3 to the -2 power, they multiply to make 6. Here we have 5 to the -2 power, and they multiply to make -10. I goofed up and put an extra sign there, sorry about that. So now look at this and say, are we done? Well, no, because we have negative exponents in the answer. So what we need to do is move them. The a to the 6 is not going to move. It's going to stay on top. There's no reason it would move. It does not have a negative exponent. The b to the -10 will move to the bottom and become b to the +10. The -3 to the -2 will go to the bottom and become -3 to the +2, because the exponent goes positive when you move it. Notice the number didn't change because this is an exponent rule. The exponent -2 means we need to move it to the bottom, and the power became +2. Finish this up, and you have a to the 6th. -3 squared with the negative included is 9b to the 10th. Take a minute, look at those two examples, make sure you're clear on those. And I should have said this at the beginning. This is really the more difficult part of the homework. This is like the last 5 or 6 questions. The first, I don't know, 15 or 20 are much, much easier, much, much smaller. They're going to work you into it, but these are the ones you need to pay attention to because, I mean, you know, think about it. On a test, are we going to give you the small ones, or are we going to give you sort of the more medium or more, you know, lengthy stuff? We won't give you the hardest ones possible, but I'm telling you right now, this is a possible test question, as is this, okay? So pay attention to the last few in the homework. They're more what we're looking at. This homework has a lot of buildup, and then, you know, the last 5 or 6 are the really genuinely real questions. So that's kind of what I'm focusing on. So if you get into the homework and you're like, holy smokes, this is a lot easier than he was making it. Again, wait till you get to the last 5 or 6, and that's where this kind of stuff shows up. So I figured we'd spend our time talking about the ugly stuff, and the easy stuff really, you know, the shorter stuff shouldn't be too big a deal. Now, quotient rule can be a bit of a pain here. So let's do 2 examples of the quotient rule here with negative exponents. Let's do one where there are no negatives, but the negatives show up. So like 6x to the 7th y squared over, you know, I don't know, 3x to the 3rd y to the 9th. And again, that is a 3. It's not showing up great here, so make sure you catch that. So we'll just do this like, this is actually from homework 8, right? 6 over 3, 6 divided by 3 is just 2, no big deal. X to the 7th over x to the 3rd, they are supposed to subtract. 7 minus 3 is x to the 4th up top, right? 7 minus 3 is 4, and it's up top because that's where there are more of. And now here we say, well, 2 minus 9 is -7. But remember, I told you in the last homework 8, don't do that. Don't make negative exponents if you don't have to. Yes, 2 minus 9 is -7, then -7 moves to the bottom. That's 2 more whole steps. Couldn't we just say 2 and 9 cancel to make 7, and there was more on the bottom, right? There is technically an intermediate step here where you have 2x to the 4th y to the -7, and then it becomes this. But I don't like taking that step at all. I would not do that if it were me. I would not say 2 minus 9 makes -7, and then what do I do with the -7? Oh, now I have to move that to the bottom. Just think about homework 8. 7 minus 3 is 4. There was more of them, so we put it at the top. 2 and 9, they cancel. Think about it. 9 y's, 2 y's, they cancel. There'd be 7 y's left on the bottom. So if you can just think it out and say, well, look, if they cancel, this is how many there's going to be, and it avoids making a negative, then do so. You could do 2 minus 9 to make y to the negative 7, but then you just have to move it to the bottom anyway, and it's just another step. Now, that being said, it is possible, quite possible, that you're just going to get ones that have negative exponents in them straight off, and it doesn't really, you aren't able to avoid it. There's no way to duck it because they're already there. This is where it gets a little troublesome. Pay attention to this one. This one is a little tricky. Negative 10 over 11. Luckily, we got a nice one there. Those don't reduce. Negative 10 over 11. We don't even have to mess with that, right? Those are coefficients. Negative 10 and 11 don't reduce. They're just going to stay the way they are. The A's. Let's do these down here. I like to do this stuff. When there's a lot of negatives floating around, I like to do them off to the side. So we have a to the negative third over a to the fifth. A to the fifth will not move. A to the negative third needs to move to the bottom and become a to the positive third, right? Because that's what negative exponents do. They move to the other side, in this case to the bottom, and become positive. Now, think about it. You already had 5 A's down there. Now you're bringing 3 more A's down there. So wouldn't you have 8 A's on the bottom? A to the 8. Now the B's. This is where it's a little more tricky. So again, pay attention, be careful. It's the same rule though. We're not doing anything different. We're just doing a lot of it at once. Here we got negative 4 and negative 3. I'm not about to try to subtract that mess. B to the negative 4 is on top and should move to the bottom because negative exponents move to the other side. B to the negative third should move to the top because negative exponents move to the other side. So in this case, because they were both negative, they both moved. And you ended up with b to the third on the top and b to the fourth on the bottom. Well, 3 on top, 4 on the bottom. They're going to cancel, and there would be 1b left on the bottom. And that's going to be your answer right there. So if you think about it and you rewind, I mean, it might seem crazy, but pause, rewind, and look back through those examples. You're going to see that in every case, all that I did is move negative exponents. They move to the other side and they become positive, and that is all that they do. But you're going to see when you get to these last few problems that that's not as trivial as it could be, all right? So let me wind this up, and like I told you, this will be a short lecture. There's only one rule. You're going to really want to practice on homework 9. And again, I'll send out a worksheet later to help you get an idea of the stuff you'll see in the test. The only other thing I'll say here is watch out for the small problems. This, for some reason, is especially true with negative exponents. Let me give you 2 examples. And honestly, well, actually, we're seeing old work. Do that paper. I don't want that to look weird. Let's cover that up. These are probably, when I do this in a traditional class, these are the questions that are the most missed on the test when it comes to the negative exponents. Not the stuff that we just did, right? Not this kind of stuff. People get that kind of stuff right because they're so worried about it. They practice it and they do fine. And then I'll throw them this. And about half the class will get it wrong. Even though they got the harder ones right. Because it's so small and so simple looking, they don't even know what to do with it. Well, remember, we just did this. We just did it in the context of a bigger problem. If it has a negative exponent, it's going to move to the other side and become positive. And because they both had negative exponents, they're both going to move to the other side. They're just going to switch sides. And then once they're positive, you just say, well, 7 minus 4, that's m to the third. Doesn't seem like a big deal, but when your mind is fixated on, big, ugly problems like this, and then all of a sudden I hand you a small one like this, it, for whatever reason, really does tend to throw people off. So be careful about this. And now, on that same note, I'll show you the most missed question from the test last semester. 8 to the negative 2. 8 to the negative 2 was the most missed question on the test last semester. And it was a different number, for everybody. Some people had 8, some people had 7, some people had 9, whatever. This was the most missed question on the test. I don't know why. I mean, people just said, it didn't look like anything I was used to, because again, they were just banking on these big, ugly problems, and you will have to deal with those. But aren't you going to be pissed if I throw you 8 to the negative 2 and you don't know what to do with it? Think about it. What do negative exponents do? They go to the other side and they become positive. Well, where is this right now? Couldn't we put this over 1 if we wanted to, right? Say, okay, this whole thing's over 1. So what's going to happen is 8 to the negative 2 if you want to think about it over 1, that's not how we'd write it, but it is. It's going to drop to the other side. It's going to go to the bottom, and it's going to become positive. Now, this is the reason I don't like to write the over 1 part. People think the 1 moves. The 1 does not move. The 8 dropped to the bottom, became positive. You left nothing up top. There has to be a 1 up there. And 1 over 8 squared is 1 over 64. It was the most missed question on the test. What do you think the answer people gave me was? They said it was negative 64. And I told y'all, and I told them too, the very first thing I said was negative exponents do not make things negative. So when you come to a problem like this and you have the number 8 to a negative power, that's not going to be a negative number. That's a positive 8. Yeah, it has a negative power. Negative powers don't make things negative. They just move them, and the answer will still be positive. So be careful, y'all. Homework 9 is one of those that, you know, a lot of it's not too bad, and it's only bad when you get to the end, and so people get this like false confidence with it. Be careful. Homework 9 is tricky, and you know, when I send out the worksheet, you'll kind of get an idea. So spend a little extra time on the last few questions. You may even want to redo them. I know, crazy idea. Anyway, that's it, guys. Hopefully that's a nice short lecture for you. Get 8 and 9 done as quick as you can, and we will move into 10 next time.